Okay, so we're going to look at problem 6.9, and this has an automobile. It's traveling down a road, and during its travel, it's accelerating. So it's from over a 32-foot section of road, accelerates from 5 miles per hour to 60 miles per hour. And while it's doing that, there's a friction force acting against it. Okay, so right off the bat, we can look at it and think about it and say, well, we're changing velocity, so we're acceleration. So a car's doing acceleration work. Now, uh, work, of course, can also be defined as a force acting over a distance. So we have a force in terms of friction, and the distance it's acting over is the 3,200 feet of road. And the direction, of course, of that force is just going to be in the opposite direction of the motion of the vehicle. So that work is considered to be negative. Okay. So what are we looking for? We're looking for the total work. We're given some initial quantities. We have the mass in slugs, 75 slugs. So we know since it's in slugs, this is going to be the USCS system. Velocities are also in USCS units. The distance is in USCS, and the force of friction is in USCS. So everything's in USCS unit system, so we know we don't have to convert to SI. We can just stay in the USCS system, right? Well, one of the things is that you can see the units here when we're talking about distances. It's in feet. Force is pound, which is fine, but we have a unit mismatch here. And the unit mismatch, we have miles per hour for our velocities. So we know we're going to need to convert those down to feet. And the other thing is that, typical unit used for work is foot pounds. So we know we've got to get this get them into the other units, right? So we got to get it into feet per second. Okay. Okay. So the governing equations for this problem, all we're going to have is our work, acceleration work, and a work of friction, which is actually acting against that. So here's our equations for acceleration work and force of friction. And the only other thing I put down here was the S, really the distance that we travel when we do the force of friction is just the difference, right? And what I did is I started off saying, okay, its initial position is 0. Okay, so it's just going through a certain distance. So it's force over a distance. And acceleration is just going to be v squared, the second velocity, minus where you started at, okay? So it could be that you're decelerating and this comes out to be a negative value, but not in this case, okay? So we have our governing equations for this problem. And the approach first is just to start to make the conversions, right? So you make the conversions from miles per hour to feet per second. So I put the conversion factors in there. And you have 7.33 feet per second. And at 60 miles an hour, that's really 88 feet per second in the other units, okay? And really now, if you look at it, it's like, okay, these are all in the correct units. And this is already in the correct units. So right now, we have everything in the correct units. And everything's known at this point. So we could just do a direct substitution in the equation for the total work. And when we do that, here's our equation. So here's our acceleration work, this part all the way up to here. And here's our work due to friction. We go and substitute in, and we come up with this for acceleration work. And here's the force of friction acting against it, or the work of friction acting against it. And here's the final result for this problem. And that's all for that one.